Hi, my name is Janie Helms, and I will be doing my presentation on the neural communication, and I'm going to focus on graded potential. So, some background. When I talk about neural communication, I am talking about how cells transmit signals to your brain so that your body can register what is going on and how they can react and even what is causing whatever you're reacting to. So the first thing you need to know is all body cells have a membrane potential. And what this means is that you have the cell membrane, and there is going to be so many substances on either side, and they're going to generally have a certain kind of charge that they want. Now, in a cell, or a nerve cell, or neuron, also called, on the inside, they're negative. There are more negatives, and then the positives stay on the outside. Specifically, there is a ratio, there is a number of negatives that it is, but I will get to that later. So the membrane potential is that potential to have negatives on the inside, positives on the out. Now, nerve and muscle cells in particular, they are called excitable tissues. Neurons, or the nerve cells, they are the ones that they can receive, process, initiate, and transmit messages. Now, when they do this, there are two types of electrical signals, two types of stages with that impulse that is sent to the brain. You have graded and you have action. Graded is going to use a passive type of current where things naturally flow from one place to another. So this is the one that I am going to focus on. Okay, so I said on the last slide that when I have, let me get my pen back here, when I have my cell membrane, that there are typically negatives on the inside, positives on the outside. And I said that there was a set number. So later I'm going to show you a graph, but I kind of like to draw it right now. So if I talk about, my little messed up graph here, how we have something called the rest potential, and when that rest potential changes, it can reach a point that we call the threshold. And when that threshold has been reached, those impulses, those signals will be sent to the brain. So inside of the cell, there is a set number. We say that its rest position is at -70. So -70 millivolts is where we start out. This is rest position. Now, if on every cell there are these channels, now there are specific channels that allow certain substances to move in. So for example, sodium or even calcium ions like to flow in, and those are positives. So sometimes they flow in, creating less negatives. So that means that when I'm at this rest, if I start to get those positive ions in here, it starts to rise. Now, if it rises far enough to -55, then it says that I've reached my threshold and those signals can start firing. Now, when I talk about graded potential, the change from a rest position to when that number changes. So when I have been polarized. When I go through polarization, I am no longer at rest. So they say that I will have a graded potential, meaning I have changed. If I get more of those positives coming in, they call that depolarization. So I am going to be greater than the -70 millivolts. I'm going to approach zero. Repolarization. Let's say that these positives stop, flow evenly spreads out, and I come back down here to my -70 and stay at my rest position. Now sometimes, if my depolarization goes crazy, when it comes back down, sometimes it goes not perfect to the rest position. If I get too many negatives in there, we say it is hyperpolarized, and I get below the -70, so deeper, too many negatives than normal. Now, how all this changes, how that graded potential changes, it depends on what triggers these channels to open and close. Okay, so what makes those channels open and close? So here, that is where I talked about right here is where I talked about what we actually call the graded potential. It's the change in that amount of millivolts. It's the change in how many of those positives, those ions, have moved in. The more that will happen, so the amount of change or the amount of graded potential, it's going to depend on how strong the trigger was and how long the trigger lasts. So the stronger and longer it lasts is directly proportional to its reaction. The stronger the trigger, the larger the change, the longer the change, the longer of the graded potential. It's only going to occur as long as it has those ions to help it do it. In physics, they have something where they talk about the spread of energy and how energy spreads out, but it can only travel as far as it has enough energy to carry. So for example, ambulance. I can hear an ambulance on the road I'm on when it's coming up to me. I may even be able to hear that ambulance on the next street over. But I can't, even as loud as it is, I can't hear the ambulance in the next town over. So the energy in that sound was enough to spread through the next road, but not to the next town. So this energy, or these ions, and how graded potential works, it follows that same scientific principle, where it goes a short distance and will only last as long as you have that triggering event occurring. I mentioned a minute ago that sodium, or even calcium, sodium is one of those ions that move in through those channels that helps with the depolarization and helps us get to the threshold. Now, these are some images of what I drew on the previous slides, and I tried to kind of explain that process. These images were taken straight out of our textbook. So what it shows is when these gates, when these channels are closed, you have the normal negative inside of your neuron with the positive outside. But then, once they open, the positives are going to move through to the inside. This is the active area. This is where the graded potential is going to change. So this is what can cause and excite that neuron. And if you have enough of these positive ions move in, you could reach the threshold and start sending signals to your brain. Here is a much nicer graph than what I was attempting to draw on the previous slide. So this shows your time in milliseconds and the millivolts for the membrane potential. Here is your rest position here at -70. Notice here at about -50, or as I said earlier, -55, that is when you have reached the threshold, meaning that you are going to start getting the action potential start occurring, and those signals are sent to your brain. Again, here's the last step where I talked about and related it to the ambulance. Here was the original active site where the gate opened. Sodium or even the calcium ions move in, depending on which channel it is. There are specific sodium channels and specific calcium channels. They're going to move in, and they're going to try and spread as far as they can. But as soon as they lose energy, as soon as there's not enough positives to help keep this process going, it can't spread to these other inactive areas. They're only going to be able to go as far as they can. And if they can't, and this channel closes, and there's nothing else to affect the amount of negatives, then it will go back to its rest position, or as they have it right here, your resting potential. Now, down here, I have where it says a question was asked. Now, this is a little outdated, but it is a very interesting question. Scientists were looking at the accuracy of graded potential and how it could move information, how it could move those impulses that needed to be sent to the brain. How was it compared to kind of a spiking event, very quick, rapid changes that occurred if they were to, let's say in an experiment, scientifically force a spike of this impulse, these changes, without using the passive current. So I mentioned earlier that graded potential is a passive occurrence, meaning there's not much energy that's taken place for it. If that gate opens, they naturally just move in because that is what that channel is made for. So not a ton of extra energy is required. But what the scientists were wanting to try was, what if it was forced? What if they made it, it's, as they call it, a spiking mode, put it in spiking mode. And what they found out was actually the spiking mode caused issues. The easy flow of graded potential allowed for more information, more of those impulses to be carried. So the normal, natural way that our body and those cells use the channels to allow ions in and out of our cells, it is very efficient. It works the way it is supposed to work. So more information was carried, and it was more successful over long spans of time using the passive current. And so here are my references. I found the 1998 article here where it talked about those active membrane properties, like the action graded potential versus the graded potential, and how those signals and information flowed through. And then here is our textbook. Now, I do want to go back real quick to, I didn't really address when I say permeability. Permeability goes through and mentions the ease of those ions going through the channels. So a triggering event, something that is occurring, I said affects how long. Now what I didn't say is what a triggering event is, or what could be a trigger. So examples of what can be a triggering event. Sometimes there can be a change on the voltage across your membrane. So there are actually 4 different types of gated channels. And so one of them, or well, all 4, you have a voltage gated channel, a chemically, a mechanically, or even a thermally gated channel. So the voltage gated, there's a change in the voltage on the membrane. Chemically means that something has it's binded from one thing to another, so a new bind or a chemical occurrence can cause it to change. Mechanically means that there can be stretching or some kind of deformation occurring with those cells or those channels. And then thermally, if there is, it's basically a response to a change in temperature. So if something occurs in your cells or around your cells and the temperature changes, those gates can open to help try to fix it and flow and give that nice level of what it should be. So for these changes specifically on this graded potential, you can have a voltage change, or something's causing stress on the cell, or there is a new binding of elements that will create the wrong kind of environment so that when we get to these other slides here, it wants to try and find that balance. If there is something going on outside of this cell that it wants to fix, it needs to open so that they can send to try and create that balance. Or the opposite. So just how gates can allow things to move in, other times these negatives or the positives, they can move back out. So a triggering event just refers to some kind of stress or occurrence on the cell, and it uses this passive current, the graded potential, to try and correct it. So thank you for listening to my presentation. Hopefully you have a better understanding of what graded potential in the neuron cells consists of. Thank you.